molecular term symbol. I have posted one video based on ground state term symbols. This video is an extension of that video. Before going to this video, watch that video. First of all, you know what is molecular term symbol. It is a shorthand expression of the group representation and angular momenta that characterize the state of a molecule. Molecular term symbol represent electronic quantum state, which is an eigenstate of the electronic molecular Hamiltonian. It is equivalent of the term symbol for the atomic state. For heteronuclear diatomic molecules, the UG symbol does not correspond to any exact symmetry of the electronic molecular Hamiltonian. In the case of less symmetric molecules, the molecular term symbol contains the symbol of the group representation to which the molecular electronic state belongs. How we can write term symbol for a molecule? First, write the electronic configuration. Then, location of unpaired electrons. The term symbol is written as lambda superscript 2s plus 1 subscript g bar u and then symmetry plus or minus. Calculation of s value and then the multiplicity, that is 2s plus 1. Calculation of lambda. When lambda equal to 0, the term is sigma. When lambda equal to 1, the term is pi. When lambda equal to 2, the term is delta. And lambda equal to 3, the term is 5. Next is to find the center of symmetry in a molecule, whether the molecule possesses center of symmetry or not. Characteristics of lambda. Lambda is related with the symmetry of electron distribution. When lambda equal to 0, there is no angular momentum. The term when lambda equal to 0 is sigma. That state is non-degenerate. When lambda equal to 1, the term is pi, that is doubly degenerate state. When lambda equal to 2, the term is delta, that is also doubly degenerate. When lambda equal to 3, the term is phi, that is a doubly degenerate state. Resultant spin angular momentum, yes. In this case, the spins couple and give the resultant value, and 2s plus 1 represent the spin multiplicity. plus and minus signs. These signs are used only in the case of term sigma, but not for pi, delta and phi. They are related with vertical planar symmetry of the molecule. In this case, if we rotate in the clockwise direction from this point to this point, if the sign of the wave function is not changed, it is positive. If the sign of the wave function changes, it is negative. Then what are the rules used for determining the term symbol of a molecule? If the symbol is sigma, then only positive or negative subscripts are used. G and U refer to the orbital of the last electron filled. Minus subscript will be written only when the electron is filled in the pi orbital. That is, when the electron is in the pi orbital, we use minus subscript. G bar U, that is gerade, ungerade. Terms are used only in the case of molecules having a center of symmetry. All homonuclear diatomic molecules possess a center of symmetry. But center of symmetry is absent in case of heteronuclear diatomic molecules. That is, in this case, no question of putting G bar U as subscript. Atomic orbital parity, bonding molecular orbitals parity and anti-bonding molecular orbitals parity. Consider the case of s orbital. The shape of s orbital is like this. If on moving from this point to this point in the clockwise direction, the sign of the wave function doesn't change. That is, it represents a gerade. Bonding molecular orbital is also gerade. But anti-bonding molecular orbital is ungerade. That is, in this case, no center of symmetry. Consider the case of p orbital. Consider one of the p orbital, that is a px orbital. On moving from this side to this side in the clockwise direction, in this case, the sign of the wave function changes. That is, it represents ungerade. That is, there is no center of symmetry. Bonding molecular orbital is also ungerade. But anti-bonding molecular orbital is gerade. That is, it has a center of symmetry. Consider the case of d orbital. The shape of d orbital is like this. That is, this is a dxy orbital. That is, on moving from this point in the clockwise direction to this point. In this case, the sign of the wave function doesn't change. That is, it represents gerate. Bonding molecular orbital is also gerate, and antibonding molecular orbital is ungerate. That is, antibonding molecular orbital is always opposite to bonding molecular orbital. The f orbitals are also ungerate like p orbital. Bonding molecular orbital is ungerate and antibonding molecular orbital is gerate. Molecular term symbol is represented by lambda 2s plus 1 g bar u, while ground state term symbol is represented like this, that is L 2s plus 1 j. When lambda equal to 0, the spectroscopic state is sigma. When lambda equal to 1, the spectroscopic state is pi. When lambda equal to 2, the spectroscopic state is delta. When lambda equal to 3, the spectroscopic state is phi. For sigma electrons, the value of lambda equal to 0. For pi electrons, the value of lambda equal to 1. Lambda is the summation of all small lambda values. That is, capital lambda is equal to sigma I lambda. This lambda can take up only two values. That is, lambda equal to lambda 1 plus lambda 2 and lambda equal to lambda 1 minus lambda 2. The total spin angular momentum is S is equal to sigma I S. Before going to the term symbol, you know how to write the electronic configuration of molecules. Electronic configuration of molecules up to 14 electron is different from those with more than 14 electron. First is the electronic configuration up to 14 electrons. In this case, the sigma 2pz orbitals are having more energy than pi 2px, pi 2py. Next is the electronic configuration with more than 14 electrons. In this case, pi 2px equal to pi 2py orbitals are having more energy than sigma 2pz orbitals. Next is how we can write the term symbol of hydrogen molecule. Hydrogen molecule contains 2 electrons. Its electronic configuration is sigma 1s2. That is like this. First find out the value of lambda. This lambda equal to lambda 1 plus lambda 2. In this case, this contains 2 electrons, therefore 2 into 0. That is equal to 0. Then find out the value of multiplicity, that is 2s plus 1. Since it contains 2 electrons, s is equal to 0. Therefore 2s plus 1 is 2 into 0 plus 1. That is 1. Then you have to find out whether it is gerate or ungerate. Since the electron is in the sigma orbital, it is gerate. Then find out the symmetry. Since the last electron enters sigma orbital, the symmetry is positive. When the last electron enters sigma or sigma star orbital, the symmetry is positive. Therefore, the term is sigma, that is the value of lambda equal to 0. Therefore, the term is sigma and the term symbol is 1 sigma g positive. Consider the case of H2 plus. It contains 1 electron. Difference from hydrogen molecule is that since it contains 1 electron, the value of S is equal to half. Therefore, 2s plus 1 is 2 into half plus 1 is 2. And the term symbol is 2 sigma g positive. Difference from hydrogen molecule is in the multiplicity. Oxygen molecule. This is an example of molecule containing more than 14 electrons. Oxygen molecule contains 16 electrons. Its electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2p z2, pi 2p x2, pi 2p y2, pi star 2p x1 and pi star 2p y1. First find out the lambda value. Lambda is equal to lambda 1 plus lambda 2. In this case, the last electron enters these two orbitals, that is the px and py orbitals. Px orbital contains 1 electron, py orbital also contains 1 electron. Therefore, the value of lambda is equal to plus 1 into 1 plus minus 1 into 1, that is 1 plus minus 1 equal to 0. Then find out the multiplicity of the term, that is 2s plus 1. In this case, p orbital contains 2 electrons, one in px orbital and the other one in py orbital. So s equal to half plus half, that is 1, or 2 into half equal to 1. Therefore, multiplicity 2s plus 1 is equal to 2 into 1 plus 1 is 3. Then find out whether it is gerade or ungerade. Pi orbitals are ungerade. When pi orbitals are antisymmetric, they are gerade. In this case, last electron enters in the pi star orbital. So, G into G is G, that is gerade. Then you have to find out the symmetry, that is positive or negative. Since last electron enters the pi star orbital, the symmetry is negative. So the term is, when lambda is equal to 0, the term is sigma 3 sigma g minus.